recording. So Alex, the floor is yours. Thank you very much.
Well, thank you very much, Enrique, and welcome everybody. Let me shuffle a few screens here and make sure that I'm able to see correctly what I want to show you. So everybody's able to see that screen now?
Yeah, perfect. Thank you.
Yeah, and you're able to hear me correctly?
Yeah.
Good. So, my name is Alex Degagné, VP of Sales and Co-owner of Minotair, and extremely happy to be here showing the Vermont Passive House Group. And without any further delay, I just want to tell you that I am unable to read your chat messages while I am. Someone is saying that, Carol, you're not able to hear me well. Is it still the case, Carol?
You could increase your volume if it's possible.
Yeah, let me do something, okay? Let me put my headset. Tell me, is it better like this, people? I've got my headset.
I think it's about the same, but go ahead.
Oh, give me a sec. No, let me change the microphone. Is it better now?
Oh, much better, yes.
Okay, perfect, great. So yeah, so I put my headset with my microphone, so it's going to be I'm going to be able to talk to you more naturally, and so good. So let me put that here. So all right, so thank you for everyone for being here. I do have a funky accent when I do speak. I'm French Canadian. I'm from the southern part of Quebec, and you're going to learn that later. So here we come. So your little cousin from Quebec, being here with you from Minotair. So I'm going to first starting by saying, that, hold on, I've got a problem here. Just want to lower something that is in my way. Sorry about that. Okay, we are. So I'm going to start to tell you something that today we're going to learn that, because just like computing, distributed mechanical system is the future. Dr. J. More on that, on Dr. J later. So today I'm going to talk to you about, I'm going to show you an ultra short intro video. The humans behind the company, what it is, how does it work, who's winning, literally using it in the DOE, the dessert for last, the live demonstration. So first of all, let's begin with a short video.
My computer just died, so I'm gonna head home.
How did your computer die?
I didn't bring the cord. The battery died.
Oh.
Oh, could you put your mute on?
Fresh air ventilation provided with the highest heat recovery efficiency ratings ever seen in the industry, and third-party certified by the Home Rating Institute, on top of being capable of sound net zero positive ventilation. Check. One thing that says it all is the fact that all our customers are returning customers, and they are not only from the private sector like Onion Flats in Philadelphia, but also from some public housing corporations. Care by Minotair, our innovative and comprehensive indoor wellness engineering approach, radically different, full trifecta, creating for you and your loved ones probably the most affordable and healthiest indoor climate you deserve and need now more than ever. Stay tuned to learn more. Broadly engineered and made here in North America for our climate zone. From us, Minotair, the science of air. So who's the human behind it all? Well, first of all, where we're located in Gatineau. This is in the Ottawa greater area. This is our main assembly plant in our headquarters. Gatineau is a city of 250,000 inhabitants. Just across Ottawa, which is Canada's capital. We're legally in existence for 9 years now.
So we're based in Canada, and Minotair is equally owned by two Canadians, which is, Carl O'Day, founding CEO of Minotair and lead engineer, and myself, Alex de Gagne. And I'm going to talk briefly about myself. So yes, I'm the VP of Sales Marketing Corner with Carl O'Day of Minotair. And I was born in Mount Sutton, which is a ski mountain village 6 miles north of Vermont border, with my father, who was a builder and a real estate promoter who was promoting quality in buildings since the 60s. By the way, I partly learned my English listening at WPDZ, Blasburg, Burlington, New York, listening at Sesame Street, So yeah, and right now I'm living 25 minutes away from Highgate Spring, Vermont, in Quebec. So it's easy for me to go to Vermont, extremely easy actually. I've been working in the HVAC technical sales since 2006, mostly for multinational manufacturers like Fantech System Air, one of the largest global group of manufacturers making ventilation products, inline duct fans, and HRVs and ERVs. I was board member of the Canadian Institute of Plumbing and Heating, Canada's largest association of plumbing and heating for manufacturers, and I am a building technologist with 2 technical college degrees about building construction and inspection. I was Passivhaus trained in 2016, being in person at the Passivhaus Institute in Darmstadt, Germany for the Certified Passivhaus Designer Program, with the final exam yet to be completed, fierce training to come. And by the way, at Minotair, we are agnostic. We work with fierce and PHI people without a problem. And as such, I was previous vice chairman of Quebec Passive Building Association, Bâtiment Passif Québec, and I'm 53 years old and father of 2 green plants, no kids, with yet to find my great love of a lady. So what do we have? What it is? Well, the genesis, an interesting story of our industry. So it's part of the National Building Code of Canada since 1995 to suggest installation of HRVs. Also, in the province of Quebec, it is mandatory for over 20 years to install HRVs in new homes. All this is influenced by the birth in Canada of 1985 of the standard CAN CSR 439 to test HRVs in ERVs for performances. Units are tested by the only North American third-party lab, Element Exova, based in Mississauga, which is Toronto, under that CSR 439 standard. And lab results are published and certified by the Home Ventilating Institute. Yeah, HVAC, which also tests, bath fans, range fan, that kind of stuff. It is a US-based organization, legally used in many building codes and respected across the USA and Canada. So yes, Americans put man on the moon in '69, but up here in Canada, well, we know a thing or two about manufacturing HRVs and ERVs with Canadian-based manufacturers like Alvis, Fantech, Labrador, Vanny, Van Mar, Minotair, plus making private labeled units for Trane, Carrier, and Lennox. Actually, the majority of HRVs and ERVs being sold in the United States are made in Canada, mostly in Eastern Canada. So how it started Minotair? Well, way too many Quebecers turn off their HRVs and ERVs in the summer, because entering air is often too hot or humid. And by the way, Montreal, just like southern province of Quebec, is as hot and humid as Boston that time of year. So Carl O'Day, who's our founding CEO, has decided to make something about that, being a good handy guy on top of being a great engineer with a military background. So after some extensive research, Carl saw that not only heat pumps can remove moisture out of the air very effectively, but they can also capture more heat in the air than actually any usual technology compared to HRVs and ERVs with more efficiency. That technology was not really used here in North America for residential purposes, but it is known for decades, has used in some industrial and commercial applications. So let's continue to see the results of his hard work now refined with our R&D team. So here, I'm here to introduce you to the all-in-one HVAC D units, D for dehumidification, taking comprehensive care of indoor climate, being heat pump based and 100% electrified, so reducing carbon footprint. Pantacare series, this is the name of our series, and we are using our innovative Pantacare formula that takes care of 5 things: the fresh air, the heating, the cooling, the moisture, and the air filtration, providing comprehensive care of indoor climate, as we must take care of those 5 things. Applications are to come, but now the work of one Pantacare V12 equals what? The work of either an HRV and ERV for fresh air, the work of a ductless or ducted heat pump, and often forgotten is the fact that we provide so much dehumidification, like up to 4 times more moisture removal than an equivalent air source heat pump. And also we do a medical grade air filtration with a standard HEPA MER15 medical grade air filtration air filter with gasketed filled with a gasket. No, so our machines is like 4 machines in one. applications are the following: single dwellings and ADUs, multifamily, the main reason why we are here today, and light commercial. Also, our products. This is serious stuff. Even if we're still considered a small, young manufacturer, growing at a very fast pace, well, with people like me with the background working for multinational companies, we are able to be in contact with great suppliers. And, in that is reassuring how, well, our most important components are made by leading and world-class manufacturers being in business for decades. First of all, the fans are coming from Europe. The compressors are made by the same manufacturer supplying Carrier, Toshiba, and Mitsubishi, and so on and so on. So because all those components are actually available off the shelf, here in North America, either from the manufacturer directly or from their wholesalers. Our products is serious stuff, certification, legal compliance. First of all, as a heat pump, we comply with CSA 22.2 in Canada as a heat pump, and we have the same certification to be used as a heat pump, in the US and under HANSI UL 1995. By the way, 1995 is the standard number, it's not a year. Plus, in Canada, in the United States, we comply with ASHRAE 62.1 for commercial use, 62.2 for residential, and as you know now, under CSA 429 as a fresh air appliance being a active heat recovery, HRV, ERV, and in Canada, CSA F326. All right, now, how it does work? Well, first of all, we provide balanced fresh air ventilation, from 20 up to 180 CFM, in 5 CFM increments, up to 1.5 inch of static pressure for those engineers out there. Also, residential noise, what's happening every 20 minutes. So the way our machines are working is every hour of the day, we work in 20-minute periods and within or 20-minute windows. So if we compare a regular HRV, ERV, running at 60 CFM, after 20 minutes, that regular machine will provide us with 1,200 cubic feet of filtered fresh air. That is normal. Us, in that case, what we do is, okay, we have a 20-minute window where we need to work, and there's a portion of fresh air that we need to provide within that 20-minute period window. So what we do is we're going to work usually faster. So we're going to provide the same amount of fresh air, 1,200 cubic feet, but working at 240 CFM for 5 minutes. Yeah, that is 1,200 cubic feet, the exact same thing that a machine running at 60 CFM for 20 minutes will provide. And the advantage of that is by working fast, but providing the exact same amount of fresh air, well, the rest of that 20 minutes, we are able to do what? To do this, provide either 15 minutes of heating or 15 minutes of cooling or 15 minutes of dehumidification and additional medical grade air filtration, air scrubbing. That is extremely important to understand that every 20 minutes, we do a better job than a regular HRV, ERV in terms of indoor air quality, and that is factual. Okay, so what do you prefer? And again, that example on the right, that scenario of running for 5 minutes at 240 CFM is one scenario. We could work 10 minutes at 120 CFM, still providing that same amount of fresh air. And again, those are examples, and our machines do adjust themselves depending on the requirements of the indoor environment and the outdoor environment. But still, every 20 minutes, what's super important to understand is every 20 minutes, we always have the same amount of fresh air in, but just working faster, providing us more time to do other useful stuff for indoor air quality and comfort. Talking of HVI, this is the certificate that you can get online on HVI.org. We've been certified for over 3 years, and the numbers are above 100%. I don't, and I'm going to explain to you why. And we have the highest efficiency numbers ever seen. So the thing is, right now, just want to double check something here. Yeah. So, let me go back, to that previous slide here to show you that how can we get to above 100%. Like I said, this is a ratio for a certain amount of heat energy. We are for a certain amount of electrical energy, we are able to capture out of this stale air more heat energy, because not only we get the heat from the stale air, but also the heat from the moisture in the stale air, and also because the compressor is on the is inside our box, the work of the compressor releases about 1,000 BTUs of free heat. So 3 heat sources, providing that we have, for each watt of electricity we're using, we're capturing more heat out of the air. So helping to make the indoor more comfortable. So the first line, if you look at the chart, heating at 0 Celsius or 32 Fahrenheit, moving 100 CFM. Well, the thing is, we have a sensible recovery efficiency of 116%. In reality, what it means that these standard test conditions are like this. At 30, the indoor temperature is always at 72 Fahrenheit at the third-party lab. Okay, 72 indoor. But in our case, when the fresh air exits our machine before getting inside a house, the temperature of the fresh air is at 102 Fahrenheit. How is that possible to go from 72 Fahrenheit to go to up to 102 Fahrenheit? Simple, 3 heat sources, like I've said. That 1,000 BTUs of heat coming from the work of the compressor is put at good use. So this is why that overall we are way much comfortable, than any regular HVAC units out there. And again, those numbers are not from us, but from the ExoElement third-party lab in Toronto, certified by HVI. Okay, so as a heat pump, we provide, almost 1 ton of cooling, about 3/4 ton of heating, that are calculated, under HR 210-40 protocol, the same as major manufacturers like Mitsubishi. Dehumidification-wise, remove up to 112 pints of moisture per day, which is a lot. Like I say, if you take, let's say, a Mitsubishi unit, which is a great unit, by the way, well, we are able to remove 3 to 4 times more moisture out of the air, which makes a big difference in comfort. Standard filtration, we have 3 filters, 2 MERV 8, 1 per coil, and 1 medical grade Apple MERV 15 filter with a gasket. Okay, so about that filter, here it is again. It has a unique gasket to ensure better air tightness, and it's about 90% efficient at arresting wildfire smoke particles. It is installed as standard with all our Pentair V12 machines. Okay, so you saw those pictures during the introduction video. So that black thing is the gasket, and we have a metallic rigid frame to make sure that we're going to have it tight, a very tight, surrounding around the filter to make sure that we will filter what needs to be filtered. Okay, and here's a graph showing that we are about 90% efficient, capturing about filtering wildfire smoke particles. Okay, and the closest competitor with a MERV 13 is at about 56%. Okay, and usually those competitors, what they do is they don't recirculate air like we do. Okay, so meaning that at the end of the day, we do a much better job filtering your air because of that alternance between air exchange and recirculation, like I explained a bit earlier. So there are ways to use the Pentair in your project. First of all, by itself with its own ductwork, it's pretty self-explanatory. You've got the machine, 2 outdoor connections, and 2 main trunks inside, one for the supply and the other one for the exhaust. One thing to point out, which is a bit different than regular HRVs and ERVs, is the use of acoustic flexible ducts that are used as mufflers to make sure that we have a quiet installation. When installers are using and following our installation instructions, nothing bad happens, And the use of acoustic flexible ducts just before the register is the way to go. Why? There, instead of directly on the machines themselves are not noisy. It's the traveling of the air in the ductwork that makes sounds, and we want to kill the sounds before the air gets inside the room. This is why we put that acoustic flexible ducts right there. Okay, and we ask for the same on the air return, because it's cheap to do at the same time. And so now, who's winning using our products? Well, the Pentair series is known as the all-in-one HVAC B units. Perfect for multifamily buildings, 1 per suite. So it's a decentralized project. So the first multifamily project we've done in the United States, was in New York State, in upstate New York, called High Bridge Place. So 20 apartments and 20 Pentair V12 units were installed at the High Bridge Place by HC, fall 2018. And they are saying that from their website, this building is also equipped with the first implementation of Minotair units in the Northeast USA, providing unrivaled levels of indoor comfort and health. You can get that information on the AHC website. Our second multifamily project is the award-winning net zero and passive house building Front Flats. And Front Flats is designed and built in. It was designed, built in and is owned by the firm Onion Flats. You probably heard about the building. You probably know Tim McDonald, who's the CEO, and lead architect for that company. And that building has 28 apartments, and what we're looking at are PV panels in front of the 2 feet in front of the exterior walls. I've been like 5 times in that building, and believe me, when you are inside the apartments, you don't really see the PV panels, and the PV panels prevent, people from outside to be what's going on in the apartment. So very, very cleverly done. So it helps for the shading of the windows, plus making, of course, electricity. So 28 apartments, 28 Pentair V12 units. So here's the McDonald's. They're under construction here, with unfinished installation. Here in the middle, still him, and just below his hand, you are able to see two tubes connecting into one. So this is for the drainage, of the condensation. And finally, this is the final look. You've got a mechanical closet right there, beside the exterior wall. And one thing I want to point out is the two drawers on the bottom are for the tenants to use. And there's the main reason why Tim decided to put the mechanical closet there in the kitchen just beside the outside wall. Actually, there are two reasons. One, you want it to be just beside the outside wall, which is not a bad idea, of course, to have shorter duct runs. But more importantly, because he owns, with his business partners, that building, he wanted to make sure that his employees, when they go to change the filters every 3 months, are able to see the state of the apartment. So I understand the reason why I've decided to do that, but it's more logical, and we discussed this, the matter, him and I, that from now on, he does recommend his customers to use that mechanical closet, but put it, still within the apartment, but with the two doors facing the public corridor. Of course, the doors are locked, but super easy access for the building, not management, but building managed crew to have access to the machines super easily without having to go inside the apartments. Okay, so yeah. So one thing that I want to point out is the electric duct heater, which is the electric backup for heat in the coldest days of winter. It's mandatory the moment our machines are to be used in multifamily or as the main heating system. So that electric duct heater takes some place because you need some straight duct section to connect to it, about 18-24 inches before and after. So to make a shorter mechanical cabinet, there's another way. The other way is to put that in a soffit, still part of the main trunk before the first branch. So instead of having a mechanical cabinet of 6 feet of height, you could have a 4 feet of height mechanical cabinet, meaning that you could design a multifamily building with having a washing machine and dryer side by side underneath it, and take use of the condensate water connection of the washing machine to make sure that you're able to get rid of the condensation from the Pinnacle unit at the same time using the same connection. So if you want to learn more about that great project, you can go to passivehousebuildings.com, and from spring summer 2020, you have a 4-page article, and rapidly what they say is that Tim McDonald, there's someone who might mute them, himself or herself, someone who got in recently. Please mute yourself. Thank you very much. So Tim McDonald said that he chose a very quiet decentralized HVAC and one for apartment, but interesting is the fact that they said they're saying that article that they are planning to use us in an upcoming project, which is bigger, called Copper Flats. That same project, front flats, one was mentioned in Wall Street Journal, and we're pleased to see a picture of our system. By the way, please, there's someone who needs to mute himself or herself. If you want to do that,
I already muted him.
Okay, thank you very much. All right, so Wall Street Journal is mentioning that great building as being an example on how to build a net zero apartment, in a very effective financial manner. But bear with me, the same picture here, but not the same website. This is The Architect. So if you are an architect or knowledgeable with architecture, you know that the Journal of the American Institute of Architects is called Architect, and that project has won a 2021 R&D award. Okay, and so we're extremely happy for Tim McDonald and On and Flats, but we're extremely pleased to know that Tim McDonald says that this decentralized approach is simpler, more economical, and easier to maintain than conventional methods. So that is extremely important to keep in mind. All right, a few advantages, that is the wall-mounted controller. There's no sensor, that thermostat-looking device, wall remote display controller. We measure the temperature and the moisture levels in the air returned within our machines, okay? So the good news is, no possibility for tenants to put ice cubes, in a plastic bag on top of the device to get more heating. Again, more clever savings. Also, we have a tenant mode in multifamily, meaning that we are able to restrict the advanced menu, for tenants, making sure that the only thing they are able to do is to strictly modify the heating and cooling temperature set points in units. And it also allows building managers to set maximum and minimum temperature limits if desired. By the way, that microcomputer that control each of our machines now is commercial grade, and we are able to change its software that runs it. It's extremely stable. It's, like I said, it's commercial grade. We found that usually on rooftop HVAC equipment, and we are using it because we are able to change the behaviors of the machine if needed, over time. So using a simple USB key. For now. So no more issues nor planned obsolescence. Our upcoming versions will use Wi-Fi, but for now, at least you're able to change, the software to have, the most recent advanced algorithms to drive the machines, Also, because we are using that microcomputer, one per machine, we are able to use a BMS, a building management system, So using Modbus to connect, permitting remote monitoring and control up to 207 units per BMS from a laptop, so that it's extremely useful. We are customers using that. Also, automatic shower detector, because we measure the temperature and the moisture in the air return, we have the automatic shower detector in parallel of a bathroom boost timer that will automatically exhaust the warm and moist air from the bathrooms outside, or during the heating season and only when the indoor air is too dry, it will automatically recirculate that warm moist air from the showers. So why waste heat and moisture in the winter when we lack water, and it's only water from a shower? So there's no indoor air quality issue whatsoever. So heating wise, it's more comfort and savings. By the way, that feature can be disabled if your code prohibits that in 30 seconds. Like I said, it works in parallel of our manual bathroom timers. So other advantages regarding that: no more need of relying on someone to activate bathroom ventilation during showers, meaning that protection of buildings' physical integrity, gyprock walls, wood studs, extra is almost not an issue anymore, meaning maximum reduction of appearance of molds, protecting people better, Also, electricity usage of high-speed fans is controlled, limited when really needed, so no more forgotten fans on, meaning no more waste of electricity and gains in energy savings. Ottawa community housing. So I'm going to talk to you a few examples of projects, where we've been involved. So Ottawa community housing, Ottawa is Canada's capital. And we've been chosen for 3 passive civil building complex in Ottawa, totaling 271 apartments, where we are delivering starting this fall, 271 machines, 1 per apartment. Also, POA, Preservation of Affordable Housing Headquarters in Boston, Mass. They are doing a very large retrofit project for 2 10-story buildings. Okay, so totaling 283 apartments. Okay, and we have started delivery of 283 machines. Started last July. So this is a cutting edge, deep energy retrofit. And during the FIES conference in Tarrytown, New York last October, I took some pictures of the presentation from Julie Klumps, who's a VP there from POA. And this is how it's going to look. And this is what they decided to do. So it's a retrofit. So they have decided to take some space, either in the bathroom or the living room or half and half, making a mechanical closet just beside the outside wall. Okay. So that's Julie Klump and myself during that conference. And that is me, with some people, the mechanical engineer, Kevin Seaman on the left, and Wesley Stanhope on the right from Building Evolve Corporation, the energy consultants, them again, and that's the crew. And we are able to see the mechanical closet. So here they have decided to use a wood bench. You don't need a wood bench. If the walls surrounding you are made with wood studs, we have straps that come standard with our machines. So you don't need a wood bench. Okay, that is it. Unfortunately, they were kind of forced to do that because someone had forgotten to put wood studs, the vertical studs instead of metallic ones, to put wood ones to be able to be load bearing. So this is why they did end up with wood benches. Okay, but 99% of multifamily customers of ours are not using wood benches. Okay, so we're saving wood. All right. So a few other customers that are worthy of being mentioned, Celebration Green and Design and Build in Guilford, Connecticut. It's a 2,000 square feet net zero and passive house, using 2 Pentair V12 units, 1 per floor. And they won Home of the Year award, mainstream green category in the Green Building Magazine 2021, which is great. I've been in that house a few times, and by the way, the owners of Celebration Green and Design are Bill Freeman and Alicia Dolce. They are co-founders of Connecticut Passive House. So they are seasoned builders, they were mentioned many times in the Fine Home Building magazine over the years. So also there's a great member. Ames Hill Passive House, welcome back in Marlborough, Vermont. This is our first FIAS certified house, and some of you are here today, like Christopher Clark Mikchik, who was the FIAS consultant. The architect was Studio Webster. The QC rater was Karen Bushy from Efficiency Vermont. And it's a joint venture from Hell Construction Solutions and Nate's Home Builders. Like I said, located in fantastic Marlborough, Vermont. So they won 2 awards. One is the FIASCon 2021 winner of an honorable mention, and they won also at the Better Building by Design. I think it was in 2019 or 2020, a best of the best. Also, still in Vermont, Evernorth, that we used to know as Housing Vermont, it's a non-profit affordable housing corporation. It's another great recurring customer. Actually, we've done a multifamily project last year of 23 units, that had been delivered in February last year. We need to deliver soon 27 units. Also, 21 units need to be delivered later this fall. And if there's a 4th project, confirmed that it's not indicated on that slide, another project in the pipeline. Also, being a Quebec-based company, we're extremely proud to let you know that your government, the US DOE, the Department of Energy, is speaking about us in the market assessment about prefabricated zero energy retrofit technologies. That can be obviously applied to multifamily. So that was from March 2020. That is public knowledge, by the way. So in their key market development recommendation, they say that they would like the development of smaller system size for multifamily units. So the Rocky Mountain Institute Realize program that they do on the behalf of the US DOE talks about the fact that they would like to see air-to-air heat pump system that could be sized as small, 11,000 BTUs and still meet ventilation loads if passive house construction techniques were used for such retrofits. Well, guess what, people? This is exactly what we've been doing for the last 9 years. So to see the US DOE looking for something like exactly like we do, we're extremely happy and proud of that. Also, something that is not multifamily, but is worth mentioning, also related with the US DOE, is the fact that Target Homes in Seattle, in Washington, they won a US DOE Zero Energy Ready Home 2021 Winner Award from the Housing Innovation Awards. So Sean Conta, who's the owner of Target Homes, has told me that the main reason why they have won is the fact they are using our technology, taking care of the fresh air, the heating, the cooling, the dehumidification, and that medical grade HEPA 15 filtration. Being in Seattle, being on the West Coast, Pacific Northwest, they had many wildfires in the last years, and believe me, they are drooling using our machines, because especially in the passive house, with our filtering technology, it's a fantastic combination to be healthy in their homes, even during a wildfire, as much as possible. So finally, the last word from a doctor, we know that with building envelopes, there's the compartmentalization principle, and also that principle can be extended to heating, cooling, domestic hot water. So unit-based heating and cooling and hot water is provided by individual mechanical system located in each unit. Distributed systems are the future. Remember computing? A lot of us do remember that in the late 70s, early 80s, computers were mainframe computers with dummy terminals. Now what do we have? Laptops. And who's that doctor? Dr. Joe Stibre. He's a PhD, professional engineer. He's an ASHRAE fellow. He has co-written, ASHRAE standards. So he's not a nobody, far from it. He's the co-founder and principal of Building Science Corporation. And by the way, that information is publicly available from the ASHRAE Journal. It's an article from July 2019. And that's myself with Dr. Joe, and at the FIAS conference in 2016 in Philly. Yeah. So the good news, folks, is we've been doing distributed system for almost a decade now at Minotair, bringing you and your projects a unique expertise, an expertise of the future available now. So now it's time for the dessert, the live demo. So so I'm going to take a brief moment to be able to switch camera. Okay, and after that live demonstration, I'm going to take some questions. Okay, so all done. I'll be with you. Like I said, unfortunately, I'm not able to answer the chat question for now. So let me close down the camera, and I'm gonna be back with you in about a minute. Okay, so hold on. All right, you should be able to see me now. Can you? Yeah.
Yeah.
Okay, good. So what we have is a simple box, which is 40 inches of width, 18 inches of depth, in a height of 16 inches and a half of height. And so a simple looking box, no frills, but everything is there for a reason. And let me open the box to you here and show you what it looks like. Okay. So it's pretty, so
We lost your audio, Alex.
sorry
You're-
about that. Okay.
You're muted.
So
Yeah.
So thank you. So what I was saying is what we're looking at is technically, physically, it is a ducted heat pump. Okay. But a ducted heat pump with some twist, permitting it to be the most efficient of fresh air appliances of all HRVs in ERVs as certified by the HVI in terms of efficiency. And I'm going to explain to you how. Okay. But technically, it is a heat pump, a ducted heat pump. So why is that? Is first of all, we've got one coil here on the right. We've got aluminum construction, which is great. We've down to the hardware. It's stainless steel, so high quality. We've got two filters. A HEPA MER 15. That's the great HEPA MER 15 filter with a gasket. And when I push the filter, it's harder at the end because it's tight because of the gasket. We have a second coil here. We've got refrigerant connection. We've got that commercial grade microcomputer running the unit, and everything is laid out, very nicely. Okay. So here, we have 4 ports on the top. The 2 ports here are for the outside connection. So fresh air in, so stale air out, stale air from the building, and fresh air to the building. And right now, what's going on is we are in air exchange. So you see the 2 arrows. It means that's the house here. And we have 2 arrows, meaning that we are in air exchange. So we are ventilating. We are in ventilation. We bring fresh air in while we bring stale air out. Okay. So in reality, the air enters here, and cross that coil. And let me go in the back to show you something. So that coil, is like a passive core in an HRV or an ERV. So the air crosses the coil, but the coil, the refrigerant in the pipes in the coil captures the heat of the stale air, but also, contrary over HRVs and ERVs, the heat from the moisture. So 2 heat sources. And by refrigerant, we bring that heat to that second coil. And that second coil preheats the outside air entering here. So we've got that fresh air entering here, crossing that coil. And wait, there's more. In the back, in the middle right there, this is the compressor. And the compressor work releases about 1,000 BTUs of free heat. So we have a third heat source, okay? And the air finally exits here, and get inside the building. So when we have indoor 72 Fahrenheit indoor air and outside 32 Fahrenheit outdoor air, and we move 100 CFM, the temperature of the fresh air exiting here is at 102 Fahrenheit. And those numbers are not from Minotair. Those numbers are for the third-party lab and certified by the HVI, okay? So now let me show you how the machine works as a heat pump, because it is a ducted heat pump. So for demonstration purposes, I'm going to ask the machine to switch to a heat pump. Usually it's done automatically, but because it's a demonstration, now the 2 arrows are chasing each other, and now the damper is moving. So the damper is moving, and I'm pointing the back of the unit. Again, I'm pointing the back of the unit, and the damper goes from front to back, from right. So in a few seconds, that unit will become a ducted heat pump instead of being a fresh air appliance. Boom. Right. So we still have the fresh air. We still have the stale air from the building. So the surrounding air in the building entering here. But because of the damper, it cannot go right anymore. The only place it can go, it's left. So it crosses the 2 filters. And by the way, 100% of the time, the air is filtered by that MERV 8 filter, a triple ply MERV 8 filter, and that MERV 15. Unimpededly, if it's fresh air getting in, or if you do recirculation, just like any heat pump, by the way, or any furnace, those machines work in a buckle. It's a closed loop recirculation. So all the time we are scrubbing the air with those 2 filters. So the indoor air is crossing those 2 filters. It gets conditioned by the coil, and the air gets back inside the building. Meanwhile, my fresh air still enters here. But because of my dampers like this, the fresh air will cross that coil and it will capture the heat or the cold from the process and will bring that back outside. What we need to understand is that coil and the compressor usually are in the box outside, but we cleverly brought inside that box those components, meaning that you don't need to have a second box outside to install a refrigerant line and that kind of stuff. So much faster installation, much easier, made in a plant, not made on the premises. So we are able to guarantee better quality of fabrication like this because it's standardized, okay, inside the plant. So this is how it works. It let me again say to the machine, hey, go back and work, as a fresh air appliance, and again, I'm doing that manually, but usually it's done fully automatically, using the smart mode, which is 99% of our customers. So now, once again, the damper is moving, going back, to become, a fresh air appliance, doing the job of nature in the ERV. So this is the explanation I get there. So let me put the camera like this, and so that's the end of the demonstration by itself. So if you have some questions, please, I'm able to take them now. We have 15 minutes left.
Thank you very much, Alex. That was a great presentation and a great explanation how it works. Please, anybody that has questions, raise their hand.
I actually have a question.
Okay, go ahead.
It's because I got to live in one of the houses that I designed. So my client was Jeff Van Pesky. I don't know if you remember him.
Jeff Van Pesky Jeff Van Pesky was our first U.S. customer ever at the very, very first beginning of our company many years ago.
Yeah, so I designed that house for him, and I got to live in it with him for a little while. And one of the things this is a very lay kind of question, but one of the things that I couldn't quite figure out is if, being New Englanders, if we wanted to set the temperature at 70, I couldn't tell if it was air conditioning or heating. I couldn't tell what it was doing in those swing seasons.
When you say that, it's because of the air, because of the temperature of the air, or because of what you were trying to understand on the screen?
Because I was trying to understand on the screen, because I knew it was running, but how could you tell whether it was cooling?
Let me take here my camera here just to show you something here. So here on the screen, now we are able to see that the temperature here, that's the moisture here, that's the temperature here. We have a flame. So when it's the flame, it means that, if it needs to heat, it means that it is in heat in mode. Okay. The set point is at 68, but it's 74 indoor here. So we don't need to do heating, but it knows that it might need to do some heating, okay, because there's the flame. If it was about to do some cooling, we would see a snowflake, as simple as that.
Thank you.
Welcome. But if I remember right, and I know I do remember right, Jeff Van Pesky sold that first house where he had a unit of ours, and he built himself a second passive house where he also put 2 of our machines in that new house, right?
Yeah, I designed that house for him too. Yeah.
Yeah. So I think people that if Mr. Van Pesky, by the way, is a builder. So if a builder, if I'm right, is he semi-retired now or retired? Kind of. It's not sure. The idea is
he's always busy building his own new houses. So he's got another project in New York now that I just designed for him. So
the good news is Mr. Van Pesky is a seasoned, experienced builder, and he built himself a second house where he decided once again to use not one, but in this case, 2 of our machines. So I think it speaks for itself.
Paul,
and I think Carol,
yeah, I'm hoping that he'll use them in this third house in the Catskills.
I think it will. Hopefully, I won't see why not.
Evelyn, I'll come right to you. Paul, you had a question?
Yeah, Alex, do you have any sort of VOC or CO2 sensors in the system so that if you have an outbreak or lots of people and you need a boost for fresh air? I didn't hear you mention anything about it.
No, I did not mention that. You are able to connect any VOC and CO2 sensor to our units very easily. of you choosing and putting them at the location of your choosing. Okay, we've decided for reducing costs without reducing quality to say that it is an option. And people will love the fact that if you want it, you buy one and you install that sensor, whatever you want. Some people are putting that in their newborn bedroom, or in their own bedroom, to make sure that 8 hours per day, they're going to make sure they will prioritize the indoor quality in their bedroom when they sleep. Okay. We're about to offer that option ourselves, okay, because we didn't sell until recently. We didn't sell that in the past. We're about to with a very easy solution with an application that's going to go with it. Okay, but now as standard, no. But the good news is, regarding the quality of the fresh air we bring, it's factually we bring the best indoor quality of any machines that is available in North America, for the facts that I mentioned earlier.
Thank you. Evelyn, go ahead, please.
Yes, thank you. This is very informative. I don't know if I missed it, but I heard that it's 20 CFM to 180 CFM of ventilation air, and the 1150 and 870, 8,700 cooling and heating. But do you have different sizes, and what are the CFM sizing?
So for now, we only have one machine. We're working on other models. Release dates are to be revealed, some of the time. But for now, this is what we have. So the maximum CFM of the units are 250 CFM. Okay, and this is but for fresh air, we say that we provide the equivalent of between 20 and 180 CFM. Okay, so every 20 minutes, let's say that you have a calculation, you need 100 CFM. Every 20 minutes, we provide the exact same amount of fresh air, but we might work faster, like I explained a bit earlier. Okay.
Yeah.
And by the way, ASHRAE 62.2 gives any manufacturer up to 3 hours to provide in a non-continuous way the exact same amount of fresh air. We do it every 20 minutes, so we are 900% compliant.
Okay, so altogether, the maximum CFM that's heated and cooled is 250 CFM.
Meaning that the ductwork has to be designed for 250 CFM.
Great, thank you.
Yeah, and the ductwork is pretty simple. It's metallic rigid ductwork like any regular HRV, ERV. The only thing a bit different is that acoustic flexible duct, that 3 feet of flexible acoustic flexible duct to install to the registers. That's it. And this is something we sell. So extremely easy. But the rest, it's the same thing, so really extremely easy. Other questions?
Yes.
Yeah, go ahead.
Oh, sorry. What is the noise level at the unit?
The unit, so it's 40. Sorry, is it? I've got a blank on memory. It's very not noisy. Actually, you have to make sure that the unit works with the compressor on. You have to put your air on the machine to hear if the compressor runs. At the back, at the last page of our sales brochure, there's the specification. The specs are there, and if my memory, is it 47 dBA? No, sorry, it's 42 dB. It's 42 dBA, yeah, 42 dBA, which is extremely responsible. It's extremely quiet for what it is. Like I said earlier, I'm repeating myself, but it's for good reason. The machines themselves are not noisy. It's if the ductwork doesn't have acoustic flex duct at the end of the run of ducts, it could be noisy. But if we have that acoustic flexible duct in place, it's not noisy.
Thank you.
And so noise is a non-issue. Just like any manufacturer, if you follow the instructions of the manufacturer, you will not have any issue. We have some issues in the past with some installers who didn't take their time to read, and they did not install, acoustic sound reducing acoustic flex like it is mandatory to do. They had issues. They had to reopen ceiling and walls, on their dime, because they didn't read the instructions. There's so much. We have a 70-page document, extremely thorough. There's 20 pages about the installation. So we're not there to twist anybody's arms, if they're not taking the proper time, especially if it's a first installation. But I would say that it's kind of rare that those situations did happen. And we train installers, we help them, and we have great success. A great example of that is the fact that, Housing Vermont, Evernorth, is a great recurring customer here in Vermont.
I have a question. We
Please.
bought 2 units for hot and humid climate, and basically because they are going to provide us cooling and dehumidification. One of my concerns there is the internal heats that the machine itself it says, because you were explaining that the compressor is generating heat. So how does that work? I mean, or how does that affect the cooling process?
It's pretty simple. The cooling numbers were the cooling performances we have in our brochure takes into consideration that 1,000 BTUs of heat, meaning that the maximum cooling will provide is 11,500 BTUs. If it was not for that 1,000 BTUs of heat, we would be producing 500 BTUs. Okay, so it's a non-issue.
Okay,
the numbers are already taking into account that fact.
Okay, thank you.
Welcome. Any other questions? Maybe a question in French. Is there a question in French just for fun? No.
Yeah.
Vous allez à Better Buildings by Design?
Oui, je vais être at Better Building by Design. So the question is, are you going to be at Better Building by Design? Yes, I'm one of the main sponsors of Better Building by Design next week, and I'm eager to go back to beautiful Burlington, and being with you guys. I've been there the last one we've done in 2019, if I'm correct. 2019, yeah, and so I'm going to be there with the same unit that you saw, so I welcome everybody to stop by, say hi, and have a little chit chat, and having a look and be able to touch, and feel the machine itself, with your own eyes.
Evelyn, go ahead.
Yes, thank you. What is the maximum length of duct to the outside that you can have?
It will vary. It all depends of the size of the ductwork you're going to use and the shape. 30 feet is I don't see 30 feet as a problem, but again, it all depends of the duct design in place, and also how many elbows, and are they 45s or 90s, 90-degree elbows or 45-degree elbow, whatever. So there are many factors, but 25, 30 feet is, I think, good reasonable number. But again, have a duct designer do your duct design to make sure we provide 250 CFM up to 1.5 inch of static pressure, which is pretty high. Okay, the unit itself, the 2 coils, the 3 filters, we provide, do bring 0.7 inch of static pressure, 0.7 inch of static pressure for the machine itself. So if you deduct, if you take 1.5 inch minus 0.7, it's 0.8. So the thing is, we like to work with 0.6 because we don't want to be at a maximum, meaning that usually a good duct design was going to end up, because the machines, they do read static pressure live, to be between 1.1, 1.2 inch of static pressure, and we don't want to be right up at 1.5. Why is that? Because we want to have some play, because sometimes filters can be forgotten to be changed. Those filters, the 2 filters, have to be changed every 3 months. But we've seen in the past, we're dealing with human beings that sometimes they're not stringent. They're not disciplined. They don't change the filters every 3 months, unfortunately. So to have the 0.2 or 0.3 inch of play gives us a chance to have the machine continue to work normally. And by the way, we have intelligent fans. There are self-sensing, self-balancing fans. So if you say, hey, I need to make sure that my unit will provide 75 CFM of fresh air, well, the machines will make sure that even if we have dirtier filters, the fans will ramp up in speed because they are self-adjusting, self-balancing, to make sure that we will always be providing the right amount of air. So that is also something that I realize that I forget to mention regularly, but it is part of what we bring. So intelligent machines the fans will balance themselves to make sure that we always provide at the end of their docks, the right amount of air, either for ventilation or for heating and cooling.
Great, thank you.
Welcome.
I have another question, Alex. Comparing a dedicated outside ventilation system with yours in a situation like one of the Evernorth situations where you have like 27, 28 apartments, how do you compare the cost? The equipment
Cost-wise, how do we
cost?
compare?
Yeah.
So factually, I've been told by some of my customers that on average, we save 25, 30%, if not more, price-wise.
Is
I wasn't there.
Is that in the ductwork or is it that in
Overall,
the equipment?
equipment and installation included, between 25 and 35, between 25, 35% less money in our case. And the thing is, those numbers were given to me by customers. And what's interesting is not only people are saving money with our machines, but they get better results, better indoor quality, better dehumidification, better air filtration. And we're able to swap, machines really rapidly. If one machine goes down or need repairs, because even the best machines out there could need some repairs, well, the good news is those multifamily projects, they keep on the premises 1 or 2 units that we include in the deal, where within an hour, we are able to, 2-minute regular maintenance personnel are able to swap in a unit within an hour, which is a first, and which is great peace of mind for building owners and building managers, because sometimes, those machines do break at Christmas time. So at least if you have in the basement 1 or 2 machines available, you are able to take care of the matter like this, So overall, decentralized HVAC solution is the future for multifamily. And right now, factually, we are the leader in North America. And we're based in North America.
You have to unmute yourself, Paul.
So I have a question on single-family homes. The heat pumps today are being rated for -20, -25 at 80% output.
Yeah.
How does a single unit of yours, say a house that's built to a passive standard, you have a maximum of 11,000 BTU heating output?
No, the 11,500 BTUs is for cooling. The heating is 8,700 BTUs. Yeah.
8,700 BTUs. Okay.
Yeah.
So it's like a 9,000 BTU heat pump.
Yeah, roughly.
Similar to
for heating.
Okay. Yeah. Okay. And do you tend? Go ahead.
Sorry again. Can you repeat? Sorry.
Do you find that in most residential situations that you have to put in 2 units?
The rule of thumb with passive house is about 1,000 square feet. Okay.
Okay. Per unit.
That's a rule of thumb.
Okay.
Ultimately, what we say, have a precisely calculated heating cooling loads.
Mm-hmm.
Okay. Yep. This is what we say. But in general, again, it's just a rule of thumb to give the brief idea. It's about 1,000 square feet. To give, I don't know if you remember, but there was that Guildford house in Connecticut, 2,000 square feet passive house, and they used 2 machines, 1 per floor. Okay.
Okay.
That's
here. We have a bigger heating degree day up here. I think.
Absolutely.
We're probably around 9,000.
And the one thing I can tell you is that, we've got a great customer being Unity Homes in Bensonwood, and they are using our machines in 2,100 square feet homes where they are using one of our machines as the base system. And they add a Mitsubishi unit because we do work with Mitsubishi, and the thing is, my machines are able to control a Mitsubishi unit. So in those Unity Homes, 2,100 square feet homes, so there's a Mitsubishi 18,000 BTUs heat pump on the main floor, and my machine is there to providing whole house fresh air, whole house dehumidification, whole house, filtration, and also heating, cooling mostly for the bedrooms on the second floor. Because the good news with us is you can supply not only fresh air in the bedrooms, but also heating and cooling, even if the door is closed. Now try that with a mini split. You're not able to do that with a mini split, right? So we are able. So Unity Homes in Bensonwood, which is highly regarded in the Northeast, does that. regular basis, you know.
Okay.
Yeah.
Great.
I have another question here in the two question actually here in the chat. How many ducted runs in a typical 2-bedroom apartment, bedrooms, bathroom, kitchen, also range hood exhaust discussion?
We need minimally 3 supplies and 2 or 3 returns, depending on the size. Okay. So this is what we have on average, and we don't take care of the range hood fan by itself. We don't replace a range hood fan. No, never, ever use an HRV near or a machine like ours to ventilate above a range. Never. Okay, it's against code. You know, so we are able to remove stale air from the kitchens, 10 feet away from the range, in parallel of a range hood fan. Technically, a range hood fan should expel outside, what's going on with the range. Okay, even Passive Institute in Germany permits now, after 30 minutes per day, the use of a range hood fan that exhausts outside. Why? It's because they realize that, especially in China, where they have more and more business, that it didn't make sense because people over there are using woks to cook food with a lot of steam. And also we know, because there's some great people at Berkeley Lab in California that's saying we must exhaust outside, cooking fumes. So it is a thing to do. So us, what do we do? Well, being 10 feet away from the range, what we do is all day long, we draw stale air from the kitchens where we have chemicals under the sink for cleaning, cleaning agents under the sink. So this is why we draw stale air from the kitchen, not to replace a range hood fan, but to take care of the chemicals in the kitchen, because we know there are some chemicals there. We don't think about them, but they are there. So this is why that, it is good practice to have, an HRV near or a machine like ours, to draw stale air from the kitchen, 10 feet away from the range.
I have another question here from Andy. What is the low temperature heat output, 0 Fahrenheit to 10 Fahrenheit?
Sorry, what's the question?
What is the low temperature heat output for low temp? What is the low temperature heat output? Yes. I guess this when the intake is 0 to 10 Fahrenheit. Andy, could you
Is that person still here?
Question? Yeah. Andy, you want to ask your questions there and unmute yourself?
Yeah, I'm curious about the heat output of the unit when it's 0 or 10 below Fahrenheit.
Okay, it's pretty simple. Our machines, they have a cutoff at 12 Fahrenheit. At 12 Fahrenheit, they still provide 3,300 BTUs. Under 12 Fahrenheit, the electric duct heater will kick in. 2 things to remember in a passive house building, especially multifamily. First of all, the heat loads will be extremely low. That's a fact. And number 2, the heat loads are going to be extremely slow. Okay, so this is why, like Evernorth, even if we're working like that with the electric duct heater that's going to provide heating the coldest days of winter, still continue to use us, and others are doing so. Those large projects, the one in Ottawa for 271 units, or the retrofit job for Paul and Salem, Mass. They have on board not only mechanical engineers but energy consultants, and they're all aware of those facts. And even regarding the fact that we have a cutoff at 12 Fahrenheit, providing 3,200 BTUs. They're super okay with the fact that the electric duct heater will provide the rest of the heating, and it's going to be kind of minimal, in terms of electrical consumption. And it's going to be, the good news is going to be full electric, no gas, So yeah, the upcoming versions of our products will be cold climate heat pumps using R32. Okay. So we are aware of that. And we are stepping up our game. We've been telling that, for a certain amount of months now, but obviously with COVID, things are slower than we would like to. But yeah, that upcoming version will not be on the market for a year and a half, 2 years, again, because of COVID. But still, we are having great success with the actual machine, the way it works, and just to see Evernorth Housing Vermont being a recurring customer here in Vermont, is a great proof that we have a winning combination. Is it perfect? No, it's not perfect, but overall, it's probably the best you can get. And once again, based on facts.
Okay, thank you very much, Alex. We are already over the hour, so I would appreciate very much your time here. I think it was very informative, the webinar, and whatever questions you have, feel free to get us an email to info@passivehousevermont.org. And
Well,
very nice seeing you. Thank you. Have a good day.
Well, thank you for everybody. Merci beaucoup, and come and see me at Better Building by Design and Product next